useful for the others. Okay. Okay, so today's session, let me also zoom a little bit. Yeah. So in the last sessions, I think we've discussed the arrays, right? What all we've discussed. Let's go back to week 5. I just scroll down the topics. I think we discussed the arrays and also the modules. Yep, week 5, we've discussed the arrays, modules, and haven't started with numpys, but today we'll start. So mostly we discussed about the arrays. So at least now everyone knows that what are the arrays and how we read the elements from the arrays. But however, we'll be recollecting the same thing again today as well, the concept of arrays, that too using numpy. So we also discussed the array methods as well. Have discussed the scope and functions. Discuss the variables, the last sessions, the modules, concept of modules. Okay, and few more examples we have covered up. So today's session, this is something like we are entering into the space of the data science. Like so far, what you have learned is Python, but we're adding more value to Python, like getting into the data science space, especially. So week 6, NumPy. NumPy is nothing but it's numerical Python. Okay, and it is also it's like NumPy is like a library. So within Python, we import libraries. So if you want to import libraries, so there is a command called import. Okay, import NumPy. So before heading into that example, let's talk about what is NumPy. NumPy is like a Python library, which is used for working with arrays, especially arrays. And don't worry, what is again the concept of arrays in the school life? You guys have learned about matrix. So it's nothing but you're talking about the matrix. But here in the concept of this programming, we'll talk about the arrays. Okay, so it also has functions for working in domains in linear algebra, frontier transform, and matrix. So there's a lot many things can be done using NumPy. It was created in 2005 by Travis. So it's again the open source. Why? Because when it says open source, many people can contribute to this library. There is a site called numpy.org. For example, if I open up numpy.org, so I get the numpy site. It's lot many things can be done using the numerical Python. NumPy means, as I said, numerical Python. So by the time it loads the page, okay, yeah. So it says NumPy. The version, current latest version is version 1.20. Okay, it's a powerful n-dimensional array. So it's used for a lot of computation. So we'll discuss how well we can utilize it. And see, NumPy brings the computational power of C and Fortran or Python. So it's lot many areas where NumPy can be used. It's not one single area. So let's take up some more examples. Okay, but why we use NumPy? As I said, in Python we have lists. So you guys have learned lists, right? That's how the purpose of arrays. But they are slow in process. That's the disadvantage with the lists and all. So to improvise this, we are getting into this structure of NumPy. NumPy aims to provide an array objects that is up to 50x faster. Okay, like a 50 times faster than the traditional Python list. If you are using the list, so the processing will be slow. Rather, you go with using NumPys. So to speed up the process, the array object in NumPy is called ND array. So we'll talk about the NDRA in the upcoming examples. I will say what we're trying to achieve and how we're going to achieve. Okay. So let me see what's missing here. It is okay. So it provides a lot of supporting functions that make working with the NDRA so very easily. So and also arrays are very frequently used in data science. That's what I'm trying to say. We are jumping into the space of data science. So especially in a single line, if I say what is a data science means, again, it's a branch of computer science where we study how to store the information and how to use it and how to analyze the data for deriving information from it. So this is what our aim is. For this purpose, we are using NumPys. So here, as I said, there's a lot of advantages and speed and performance, increasing the performance as well. That's the reason, as I said. So why is NumPy faster than list? That's one more thing. Okay. So how come you say that someone says, okay, why NumPy is faster? NumPy arrays are stored at one continuous place in memory, unlike lists. So that's a reason. Okay. So processing can be accessed at a faster rate. So NumPy arrays, that means the data in the matrix format are stored at one continuous place in a memory. And it can also be manipulated very efficiently. So this behavior is called locality of reference in computer science. So this is the main reason why NumPy is faster than list. So there might be an interview question if someone is trying to attend the data science interview or something like that, or like in Python Python developer interview or something like that. Then so this answer will be helpful, right? So we can use NumPy and we can explain them saying that why NumPy will improve the performance. Okay. So, and also it is optimized to work with the local CPU architecture. The CPU is a central processing unit of a laptop or a desktop, the local machine. So it works closely with the local machine rather than with the remote. So in which language is NumPy written? So NumPy is a Python library and it's written partially in with Python, but most of the parts is written in C and C++. If you guys have learned of C and C++, so most of the coding has been written in C, C++. That's one more thing. And let's jump into how we can utilize NumPys and what are the advantages. So just before getting into this example, let me go back and say, if someone has got a Python install, it's not mandatory that you can straight away jump onto the coding of a NumPy and straight away run the code. Sometimes it may not work. The reason behind this NumPy libraries to be installed, right? So installation of NumPy, install it using the command. So if you want to jump onto the command prompt, use this Windows Start menu and say CMD command prompt. And once you get onto it, so something like that, hi, here I'm using like C user, right? So here you can say there is a command what I say is pip install Python. So if I say pip install, sorry, it's a pip install NumPy, pip install NumPy. So when I say the pip install NumPy, it will try to see, right? Is collecting a NumPy and downloading the NumPy libraries and say installing collected packages. Okay, you're using pip version, however version is available. You should considering upgrading. Okay, so it says python.exe. It says install upgrade. Yeah, it says to upgrade to the latest version, but that's okay. But at the moment I already have what it is trying to say is already have this NumPy, but with a version, as I told you, NumPy here is 1.20, right? Here that is for the NumPy, but here with this Python version also here we got 20.2.3, but however the latest one is 21.1.1, right? So we don't need to upgrade at the moment, we can still manage, But the command, if you think that the numpy code is not working, just use the command pip install numpy. So that too in the command prompt. So just to get into the command prompt, use this Windows menu and type in cmd command. So that's how you get into this command prompt window. So once you get into the command prompt window, just type in pip install numpy. So this is one of the highlighted one. So just in case. Okay, Donald join. Okay. So this is a command, and just in case if it doesn't work, the other way around is, as I said, Anaconda. So as I told you, Anaconda Jupyter. So you guys have installed this Anaconda software, which I've explained in the first session, like an Anaconda software. When you install Anaconda software, you'll get this Anaconda navigator window. And within this Anaconda navigator window, you can straight away jump into this Jupyter notebook and say launch. So once you click on the launch option, you get this Jupyter sessions open, and you can start writing the Python codes and start utilizing it. So that's what the other way. Is some people will be using like a Python from the Python site itself, straight away from the Python site. So in that case, you will not get this option of NumPy. But just in case if you are already using Anaconda, it will be like an inbuilt. And if it doesn't work, just use this command, right? So, and within this, now we'll start applying the arrays and how the concept of arrays will work. So once the NumPy is installed, import it is your application by adding the import keyword. That is what we're trying to say, right? So import NumPy, when I say anytime we start with the code, it says import NumPy. That means we are importing the library. And then, for example, if you're using an array, right? So array equals to numpy.array of 1, 2, 3, 4, 5. And when you print the array, you get the array details. And just in case, if I want to know what is the type, right? The same example, if I remove it from here, right? So that's a dummy one, and let me place it under this one, right? So let me run this and explain you. So here, what I'm trying to say is import numpy as np. So this is one more thing. Before heading into this, probably I need to explain about this concept as well. So as I said, NumPy library, right? The other way around to make it is like an alias format, NumPy as NP, we can use it, treat it. NumPy is usually imported under the NP alias. So alias type, we treat it as NP. So next time when you try to write a code, import NumPy as NP, that means you're giving as a short name. So instead of using this NumPy, you can say NP. So array you're treating as NP dot array. And in that way, it's like we're creating an alias with as a keyword. Okay. In Python, alias are like an alternative name for references. Right. Now the Python package can be referred as NumPy instead of referred as NP instead of the NumPy. So here, what it's doing, import NumPy as NP, and when it's a print of the array, it is printing the array 1, 2, 3, 4, 5, and we are also trying to say what is the type, right? So what it is trying to say, it's a class of NP and ND array. Okay. So let's get into the deeper sections of these arrays as well. Before that, we'll see some examples. Like simply when I say import NumPy, NumPy as NP and array, so it just prints 1, 2, 3, 4, 5, right? So let's see if what kind of version, as I told you, currently the NumPy, which has been already installed. So import NumPy as NP and print NP dot versioning. So what happens is it will try to say which version of library we are using it, right? So there are other ways. So here we can, as I said, you can use the list and we can use the tuples as well. But just in case if you have used the tuples, use the tuple to create a NumPy array. So import NumPy as NP is a common word we are using it. So at this time, we look at the brackets here and look at the brackets which I've used here. There's a difference. So don't get confused. So here we are using this tuples, and so we get the values over here. So let's see, uh, get into the deeper of the concept of the dimensions. So we get the concepts like a zero dimension, one of first dimension, a second dimension, or the it's like in 1D arrays or the 2D arrays or the 3D arrays. That is what we'll try to explain, and the like in 5D arrays or something. So for example, here we talked about this tuples concept, and now jumping into the dimensions. So as I said, don't get confused. You just need to keep in mind like an matrix from a school age. So here it's like an zeroth dimension when I say, so 0D arrays or the scalars are the elements in array. So what it is trying to say is each value in an array is a 0D array. So how it is treating? Example. So array of NP of array, it's like in 42. It's once, that means we are assigning only one value to it array. We don't have any two-dimensional or one-dimensional or something like the 0th dimension. So how do I say that? Okay, if it is like an 1D array, so this is like an 1D array. Okay, so 1D array concept here. So how we are treating this 1D array, how we are giving it like an only this particular line will be different. ARR is like a keyword we are using it. You can use any other word as well. np.array. So 1, 2, 3, 4, 5. These 5 values we are assigning, and that means it will be in the one single dimension. Okay, so we don't get 2 rows, we'll get only 1 rows, right? And the same case, if we want to print, I'm going to use the same thing, but just in case if you want to pick up only the first value in that array, so just keep in mind the array treats starting with the 0th element. These are all the elements inside. So here the 0th element, and this is 1, is 2, 3, and 4. Don't think that this is 1, 2, 3, 4, 5. Just start with the 0th one. So if I want to print the first item in the array, like in first element, we call as a NumPy array indexing. However, we'll discuss in depth regarding the indexing. This is what, when I say array of 0, right? So what it is trying to say is, so there are two print statements. One is a print. When I say the array, it's printing this 1, 2, 3, 4, 5, right? And this say array of 0th element, like an 0, this is a 0th element, right? This is 1. And just in case if you want to print first element, so like an 0 is 0 and this is 1. So it's like a second element, but here it starting is the 8 zeros value and 8 ones value, right? So this is 2, right? So as I said, it starts with 0 in the array. Don't get confused. We're talking about elements means 5 elements, 1, 2, 3, 4, 5. And the array of 0 is 1. Array of 1 will be 2. So here if I say array of 0, and when I rerun the code, I get as 1, right? So if I remove this, if I just comment this element to get rid of the confusion, okay? Well, because we already talked about how to print an array. So here when I rerun it, I get the value is 1. That means array of 0 is 1, right? So just in case if I want to print this fourth element, all right, 0, 1, 2, 3, let's see what it gives. So its array of fourth will be like 0, 1, 2, 3, 4, 5, right? So this is the fifth element in the array since starting with 0. So print the first element of the array, like can I say, this time it's a fifth. If I let's change it, the printing the fifth item and this one like array of 4. So let's talk about the 2D arrays, how we are going to define and how we're going to utilize it. The same concept of this 1D array, but create a 2D array containing 2 rows with the values 1, 2, 3 and 4, 5, 6. So here arrays will be represented this braces, right? Square brackets. So 1, 2, 3. So we got braces closed. Again, here we got 4, 5, 6 with braces closed, and we got the starting and the closing braces, right? So when I run it, so this is the output. So this is the two-dimensional array, right? So we just need to understand this is the first row and the second row, right? So the two-dimensional array. So let's talk about the three-dimensional as well, right? Just in case to understand. So the same concept, but little bit the improvised version, right? Is look at this number of opening brackets and look at the closing ones, right? So there's a difference. So creating a 3D array with 2D arrays, both containing 2D arrays with elements of, okay, we're giving an example. So we are going ahead of a 2D to 3D array. So just when I run this, you get this format. So don't think that they both are the same. They're just different. So here, until here, this is a 2D array. This is also a 2D array. But on top of this is calling as a 3D array, right? So the syntax format and everything, which you need to keep in mind, right? So apart from this example, the same thing which has been placed over here. On top of that, we got another braces over here, starting and the ending. And that means we are using a 2D arrays, two 2D arrays, and the braces makes the difference. How you can say there is a 2D array or like a 3D array, right? So how we can read the elements within these dimensions. So how are we going to read? That's a thing which we're going to uh, do right now. Let me see if it's all fine. Yeah, recording. So check number of a dimension. Okay. So before heading into reading these dimensions and all, let me see that the same examples which you have discussed in the previous examples. So what I'm saying is AP is we are assigning to np dot array of 42. It is like an zeroth dimension, and here B is assigned to 1, 2, 3, 4, 5. It's a single dimension, right? So I want to ask the Python like what is the type, check how many dimensions are there in the array. Okay. And there's a command log like if it is an A is assigned, right? So A dot endim. So what is this type? If it is like an B dot endim, C dot endim, and D dot endim. So we are using this single dimension and the double 2D, so 1D array and the 2D array and the 3D array. But we are asking Python like an, okay, tell me what is that when you run it. So it gives like it's a zeroth. Okay, this is a 0D array, then this is a 1D array, this is a 2D array, and this one is a 3D array. So check the number of dimensions. So NumPy array provides the ndim attribute that returns an integer. So we're just trying to find out, okay, integer that tells us so how many dimensions the array have, etc. Okay, so let's take one more example, like an higher dimensional arrays. So we've seen like a 2D and 3D, and now we're going with like an, for example, if I want like an 5D array, how we're going to define, right? So higher dimensional arrays, an array can have any number of dimensions. Just bear in mind. And how we are going to define the arrays, that's the key point. How we're going to define. So before heading into this advanced Python, so once you have the good concept of numpys and pandas, then you will be able to become easily a Python developer easily. So for example, an array can have any number of dimensions. When the array is created, you can define the number of dimensions, right? So by using the ndim argument. So here, create an array with 5 dimensions and verify that it has 5 dimensions or not. So as I said, import numpy as np. This is a normal command which we need to give to import the libraries, and assigning an array of np.array 1, 2, 3, 4 and ndim of 5. Okay, how is going to represent in this 5D 5-dimensional format? When I say print, so what it is trying to do is, see, look at the number of opening ones 5 times and number of the closing ones. I didn't give here, right? So it is going to assign those closing and opening depends upon the ending value. So print the number of dimensions. So it's like number of dimensions, 5 dimensions. Just in case if I want to say 6 dimensions or something, okay, run. Look at the number of opening. 1, 2, 3, 4, 5, 6, right? 6 opening and 6 closing. So that's the difference, like, and how many are opening and how many are closing ones. So number of dimensions are like 6. So you just need to be careful, like what we're trying to do and what we're trying to achieve out of it. So endim has got much significance, okay? And nth dimension is like a 6th or 7th or 8th, or as I said, we can have any number of dimensions, right? So that's a advantage. So here when say 6, let's convert to 6 dimensions and verify that it has 6 dimensions since I've given endim equals to 6. Okay, and don't worry that you got only 4 elements. No, so we can still have the elements inside, but whatever values assigned, that's been displayed. So let's get in deeper, like in so what you're trying to do in the above example, in this array, the innermost dimension is a 5th one. For example, let's make it as 5th only. Why? Because I'm explaining this sentence in detail to get rid of the confusion. Okay, let's pick up like in 5th one. So here in this array, the innermost dimension, the 5th one, right? So this is 5 braces, right? Has 4 elements only. Yes, absolutely 4 elements only, 1, 2, 3, 4. The 4th dim has 1 element, that is a vector, and the 3rd dim has a 1 element, that is a matrix with a vector, and the second has 1 element, that is a 3D, and the first dim has 1 element, that is a 4D. So it's just trying to say, like, in how which one is a 4D and which one is a 3D and which one is a 2D. So this one, it's talking about this 5D, right? Innermost, right? This is a 5D, and this is like an 4D. This is like an 3D, right? And this is like an 2D, right? So the last one. So it keep trying to explain like and how we're going to define it. So we are not going to use these as a side of this type of examples, but we are going to get into deeper. So let's pick up the concept of indexing as well to understand these dimensions, and then we'll try to see how we can pull the elements from the array. So then it will be easy for you guys to understand. So for example, indexing, as I said, 0th element, right? Numpy array indexing, access array elements. Array indexing is the same as accessing the array. Array indexing is the same as accessing the array elements, but they're slightly different. Like in how we can say it, you can access an array element by referring to its index number. So we are giving like an index number. So the index in the NumPy array starts with 0, meaning that the first element, okay, has an index 0. That is what it's trying to say. And the second has an index value of 1, right? So when I say 1, 2, 3, 4, so 0th element, 0, 1, 2, and 3. So when I say print array of the 0th element, right? So 0th portion is 1. So that it is trying to say. So let's say the second element, get the second element from the following array, right? So this time when I want to get the second element, array of 1, it doesn't mean it is going to print 1. Is 1 means 0th element and the first element, that is 2. And this time, get the third and the 5th element from the following array and add them. Okay, so understand. So a array of 2 will be like 0, 1, this 0, 1, and 2. So array of 2 will be 3, and array of 3 will be 4. Like 3 plus 4 will be 7. So first of all, it will pick up which is the array of 2, third value, and array of 3 will be the fourth, and just add them up. So that's what it's trying to do. So let's get into the deeper accessing the 2D array elements. So that is a single dimensional one. like 1D array elements you're trying to print and add them. Now let's see for the 2D. To access the elements from the 2D array, we can use a comma separated integers representing the dimension and the index of the element. Example, access the second element of the first array. Okay, let's see what we're trying to do. Here we have assigned as 1, 2, 3, 4, 5. Okay, and 6, 7, 8, 9, 10. So look at the braces, right? It's a 2D array. So based on this, so you open and close it here, then comma, then open and close it here, and then finally open the close brackets, right? So now by that it becomes a 2D array. So print the second element of the first day means array of 0, 1. It's giving us 2. Why it is giving 2? 0. It's starting with the 0th one, right? So here, second element of the first day. So it's when I say 0, 1 in the sense, so 0 is a 0. It starts with 0, right? And then the 1, so it's 2. So array of 0, 0, 1, the second element of the first dim. Let me run this. So this time, if I change it to 1, 2, what will happen? Forget about this text and say run it. So it's pinging as 8, right? So since this here also is just even though it is 2D, this is what like an 0th, and this is like an 1th. So it's like an 1. This starts with this dim status like an 1, 2. Like an it says in this elements list, it starts with 0, F0, F1, and F2, right? So 0, 1, 2. So this is the 8. So that's the reason this number 2 represents. When array of 1 here, what it is representing is, it's not representing this section. It is representing this particular section. Okay, that's the reason 1 and 2. Now, just in case if I give like 0, 2. So 0, 2, what it is written as here 0, that means these elements, and 2 in the sense 0, 1, 2, right? So the third element, just in case initially I try to pick 1, right? So that is what the reason is. So when I 0, 1 will be, so the second element of the first dim. Okay, you got the first dimensions over here, but we need to start with a of 0 and the second element. So we want 2 to be printed. So second element in the first dimension. So you just need to be careful like what we are trying to pull out of these dimensions. So that's the reason I mentioned over here the example, what it is trying to do. So this example text will, this notes will help us, right? What you're trying to achieve. So second element in the first dimension can be pulled out by array of 0, 1. Okay. So the first dimension and the second element which you're trying to extract. Now access the fifth element of the second dimension. Here we discuss the first dimension and discuss the second element. So here the same thing, and but print fifth element of the second dimension array of 1, 4. As I said, so when I say 1, it goes to the second dimension section, and 4. Okay, so 0, 1, 2, 3, 4. As I said, it starts with this within this dimension 0, 1, 2, 3, fourth element. So this is the fourth element. This is what the factor is 10. 10 we got. Fifth element in the second dimension, we got 10. How we got 10 in the sense? So when I say array of 1, it goes to the second dimension straight away. And when I say 4, it starts counting with 0th position, 1, 2, 3, and 4 is 10. So accessing the fifth element on the second dimension. So there's one more way where we put the comments. As I said, usually we put the hash as a comments, right? So rather than we can put the comments in the sense of quotations. I don't want to put the hash for each and every line. Rather than I use the multi-line strings as a comments, just to give you an heads up. Like, and within three quotes, I add in some text. If I remove this text and if I put it, place it underneath over here, the whole information is been commented now, right? Rather, if I place this quotes over here, that means only this particular section has been commented. So now what we're trying to do is access 3D arrays. So how are we going to access the 3D array? To access the elements from the 3D array, we can use comma separated integers representing the dimensions and the index of the element. Example, how we're going to give. So what we're trying to do here is access the third element of the second array, right? So it's a 3D array, right? So here it's like an so this is what like in single 1D array representation here. Okay, and once we want to go to the 2D array representation, so this is like a 2D array representation, the braces represents. And if I want to jump to this 3D array representation, so the whole bit is like an 3D array representation. So if I want to see how does a 3D array look like, right? So the 3D array will look like in this format. So this is the 3D array format. Yeah. So this time I want to read the element, third element, right, of the second array. So this is the third element, right, of the second array. Like in first array, second array, third array, fourth array, you got arrays. So this, see, we got the output 6 means how we got the output 6. Let's explain here. I got the nodes underneath as well, but before that 0th. So this is the 0th. Okay, and within this again is strong to say 1 comma 2. So let's get into the deeper example, like, and what we're trying to achieve. So here what we have is, we says print array of 0 1 2. What it is trying to do, it is printing the value of 6. So how did it get to this conclusion that 6? Okay, so what is the answer behind? So just keep in mind, the first number represents the first dimension which contains the two arrays. Okay, here 0, what you say is array of 0 means the first number represents the first dimension which contains two arrays. Yes, so here it contains two arrays, right? So what all we have, it 1 2 3 and 4 5 6, right? The same thing. So this is what I was talking about. So here whatever we have is 1 2 3 4 5 6. So to bring the value 6, first need to separate the bits and pieces. So we need to come to this only this particular section. Okay, so the first number represents, so array of 0, so this section, and the first dimension which contains two arrays, right? 1 2 3 and 4 5 6, the first array, and 7 8 9 and 10 11 12. So the first number represents the first dimension which contains the two arrays 1 2 3 4 5 6 and 7 8 9 10 11 2 10 11 12. Since we selected 0, we are left with the first array, right? So we are picking with the first bit. So the second number represents, so here 0 comma 1, the second number represents the second dimension which contains two arrays again within this. So here out of this 1 2 3 4 5 6, so only this bit we are trying to say 0 comma 1. So 0 means we are picking up the 0 this element, and within this comma 1 means again just go to this line. That is what we're trying to say. Since we selected 1 0 comma 1, we are left with the second array 4 5 6, and then we got last bit 2 also, right? When I say 4 5 6, so the 0th element, this is the first element, and this is the second element. So what we need to print, we want to print the second element. So the third row represents the third dimension which contains the 3 value 4 5 6. Since we selected 2, we end up with the value 6. So after this session also, please go through this explanation. What I'm trying to say, simple way is, since it is a 3D array, don't get confused. So this is like an if I say only this portion is a 1D array, and if I say 1, 2, 3, comma again 4, 5, 6 and all, this is like a 2D array, right? And in the same format, we got the 2D arrays and the opening and closing brackets. Now it becomes a 3D array, right? So within this 3D array, we are trying to pull these elements, right? 0, comma 1, comma 2. When they say 0, just starts with this bit. And when I say 1 and go to this second dim, and when I say 2, go to the third element, right? Because it says 0, 1, 2. So that is what the option is. So let's, however, if I run these comments also, you get this bit, just ignore it. It's not necessary. Just the reason because is put in the comments starting and ending for the explanation, example explanation. So how we can define like a negative indexing? Use negative indexing to access an array from the end. Okay, here also I given the comments. So the same concept of import numpy as np, the same thing, and I'm giving this 2D array over here. But within the 2D array, what I'm saying is print the last element from the second dim. So second dimension, dim means dimension. So you've got a first dimension 1, 2, 3, 4, 5, and second dimension is 6, 7, 8, 9, 10. So straight away, when I say array of 1, comma minus 1, that means 1 will be this is second dimension, and minus 1 will be starting from backside. Okay, starting with this reverse time, like a minus 1, right? So since I said the elements usually starts with 0, right? 0, 1, 2, 3, 4. But when I say minus 1 means in the reverse order from the backside. From here, like this is like a minus 1, this is like a minus 2, minus 3, minus 4, like that, reverse order. So the last element from the second dimension means, so if you want to jump out of the second dimension, use array of 1. And if you want to bring this last element, use just minus 1. Just in case if I say minus 2, let's see what it will show. Okay. So it's showing as 9. Why? Because as I said, last element will be minus 1 and this one will be minus 2. So dim 2, dim will be 9. So as per the example, we want the second element, last element from the second dim, let's use minus 1. Okay, let's rerun it to get rid of the confusion. So second dimension, last element, 1 comma minus 1, simple, right? So last element from the second dimension will be this. So the reason why I'm saying is in future when we write a program to the client, they'll say, okay, I want this particular example, this values to be printed. So we need to think of the logic, how we can print the last element from the second dimension. So this is what the logic behind is, right? So I can simply say I can remove this element, this all the text also, and I can simply run it. I get the value 10, but you guys will get confused like, what is this 10? So to understand like what I'm printing, last element from the second dimension is 10. That is what. So next thing is slicing. Okay. So far we have discussed about the arrays and all, right? Next thing is slicing. How we can slice the arrays, how we can chop the arrays into pieces, right? Slicing arrays. Slicing in Python means taking elements from one given index to another given index. We pass slice instead of index like this, like a start and end. We can also define the step like a start end step. If we don't pass a start, it considered as 0. If we don't pass end, it considered as length of the array in the dimension. If we don't pass step, it considered as 1. So don't worry about these notes. Okay. Let me give an example, straight away example, how we can slice the elements. So slice elements from index 1 to index 5 from the following array. So since we got the array elements of 1, 2, 3, 4, 5, 6, 7, but I want only 1 to 5 array of, okay. So here it is picking up when I say array of 1 to 5 in the sense, so here to here. So how it is treating? All right. So print array of, it's not like 0th position. If I say 0th position, it will be different. If I say 0 and 5, the results will be different. See, 0 to 5 will be like 0, 1, 2, 3, 4, 5. Here it's printing 0, 1, 2, 3, 4, 5. But rather than here, I'm asking like slice elements from index 1 to 5, index 1 and index 5. So then we are giving like an ARR brackets. So just be mindful that what we're trying to give here, the concept is different. Here the concept is different. 1:5, right? So when I give this portion, this bit like in 2, 3, 4, 5. So index starting with 1 and index with 5, right? So 0, 1, 2, 3, 4. But so since we have these indexes, right? So, but it won't print the fifth one. It says A of 0, A of 1, 2, 3, and 4. But here, in this case, when I say 1 to 5, so this is 1, this is 2, this is 3, and this is 4. The fifth one, it won't print. It won't print 6 value, right? When I say RR of 1 to 5 means 2, 3, 4, 5. That's what they usually the concept, the Cognos starts with. The Python starts with. So here, print array of 1:5. So what you're trying to do? The result includes the start index, but excludes the end index. So this is what I'm trying to say. When I say 1:5 means 1, 2, 3, 4, 5. That means 2, 3, 4, 5. It won't go until like 5 elements like this, right? So the results includes the start index. Starting index means this is A of 0, A of 1, A of 2, A of 3, A of 4, and A of 5. But it won't print this A of 5. So here it prints 2, 3, 4, 5. And the result includes the start index but excludes the end index. Just in case if I print 1 colon is like an 7. Okay. 0. Let's see what it is gives. So it's giving all the elements. You have 0, you have 1. So F1 is 2, 1, 2, 3, 4, 5, 6. So even we don't even 1 to 7 also, you can simply say 6. But of course, it will exclude the last element. That's the reason we are saying yes, you have 7. So that is what you're saying. The result includes the starting index, but exclude the last ending index. So that's the reason when I say 1:6 to get all the elements starting from here to here. Okay. But as per the example which we discussed, just say 1:5, that will 2, 3, 4, 5. So we are trying to slice the elements out of the array. So let's give some more examples, like slice elements from index 4 to the end of the array. So here, these two lines are common in all the examples, but here is a print array of 4 colon and I left it blank, totally blank. So what it does is A of 4 will be like A of 0, 1, 2, 3. So here, when I say this thing, the same concept, A of the 0th position, 0, 1, 2, 3, 4, A of 4, right? That will be the fourth element. A of fourth element will be 5, 6, 7. It is printed. Whatever, if there are like an 8, 9, 10, 11, whatever, 8, 9, 10, 11, I got these many elements. And if I run it, so you got all the bits and pieces after this fourth element, right? A of 0, the A of 4. So it says 4, right? Array of 4. So whenever it says 0th element, 1, 2, and 3, right? So after this, what are the elements are there? It has to be printed. 0, 1, 2, 3, and 4. So the fourth is starting with number 5 and all the bits and pieces. So just in case, if I want to go in the reverse direction, reverse in the sense, 4 colon we are given, right? Instead, colon 4. Reverse format. Instead of 4 colon and 4. So this time, what it is trying to say is, So slice elements from the beginning to the index. So here what we have done is this fourth element, whatever the element it has started, and it's moving forward. And in this case, it's not moving forward in saying that colon 4 in the sense you start with the first element and bring all the elements onto the fourth element. That means we got a 0, F0, F1, F2, and F3. So fourth will be excluded, right? That's what slice element from the beginning to the index 4 not included. So 1, 2, 3, and 4. So this is what it's been included. So since we have learned about the slicing, and now we can see negative slicing. How does the negative slicing will be utilized over here? So negative slicing, use the minus operator to refer to an index from the end. Example, slice from the index 3 from the end to index 1 from the. So here what he's trying to say is these two are the common things, right? Import numpy as np and array of np array 1, 2, 3, 4, 5, 6, and 7. So print array of -3 and -1. So when I say -3 and -1, it is giving as 5. Okay. So let's pick 5 and 6 is beginning. So -3 to -1. So let's say, so 0 is like a -1. It starts with negative slicing, use the minus. So the last one, it won't pick it up. So 5 and 6. The 5 and 6 will be 3 to 1. Yeah. So -3. It says -1, -2, -3. Yeah. So it won't start with here like in 1 and 3. Let me run it. So what we got here is, okay, let's, okay, yeah, 5 and 6. 5 and 6 in the sense, use the minus operator to refer to an index from the end. Yes, from the end. Example, slice from the index 3 from the end to the index 1 from the end. Yeah, it's starting from here only. So here it's taking up like in 5 and 6 to, okay, let's make this slight change. Let's make up as -4. What it does, let's see. Run it. So when I say -4 and -1, it's giving us 4, 5, 6. Yeah. So what it is trying to do is, again, it's starting in this reverse order from here to here, right? So from here to here. So you're giving us 0, 1, 2, 3. And yeah, it's keeping up this fourth element. So the same format. So it's like we are applying the negative slicing, like a negative indexing over here. I think we have learned about this negative indexing over here, right? So the negative indexing, what you have learned is here is first array, like in last dimension from the second, last element from the second dimension. So this is second dimension. And we pick this like last element, we are giving us -1. So -1 is the last element which we have discussed. So the same case, so it was supposed to be like, in what I understand, like -1, it's supposed to be 7. Ayan, what do you think? Since it has given us -1, it's starting with 6. Why not with -7? Okay. Let's pick up this one. Why? Because we're using the slicing and negative indexing. That's the reason it is picking up. So let's use the previous example only, like a -3 and -1. So let's run is. So here it's picking up as 5 and 6, like an -1, -2, -3. So -3. And yeah, that's a good question. Yeah, and I got it now. I got it. Why it is not giving the seventh element? Why it is giving only 5 and 6? As I said, it will exclude the last bit, right? That's what the Python behavior is. It will exclude the last bit, right? So when I say -3 and -1, so this is -1, -2, -3. So 5 and 6 we are getting. Why we are not getting 7 in the sense it won't pick up the last one. So that's what we say is the last. It will always exclude the last index, right? So that is what happening over here. It's not giving 7 because it will exclude the last index, even though we are giving this negative slicing. So there, yeah. Yeah, that's a good catch actually. So just bear in mind that if you want to get the last element also, then we shouldn't be using the negative slicing method. We need to use like a normal slicing method instead of going with this negative slicing. Then it will definitely bring it up. I think if we give like an, it won't be like -0. We can't use it, but yeah, I think this is the best example. Like -1 to -3 to -1 is a negative slicing. So let's do one more example, like step. How we can utilize the option of step. So step is use the step value to determine the step of the slice. Example, return every other element from the index 1 to index 7. Every other element, right? Like an alternative element. It's not like continuous elements. You jump to one step. You pick an element. For example, here I'm saying print one, print array of 1:7:2, right? So here what I'm trying to say here is, here you go through all the elements and jump like a step, two steps, in the sense, here it's keeping the first element, right? Like an starting with 1 to 7, right? So step 2 means it's giving 2 4 5, 2 4 and 6. See, 2 we got the result 2, and 3 is skipped, and 4 and 6. So every alternative element will be skipped and will be displayed. And what he's trying to say is return every other element from the index 1 to 7, right? Index 1 to 7. So it's like an A of 0, right? So A of 0. So we are not giving A of 0. Otherwise, it would have started with this element. But index 1 to 7, that's the reason. Index 1 to 7 and skip 2. That means it's like an every alternate element. So 2, 4, and 6, right? Let's see if I skip like an 3, what it will react. See, 2 and 5. See, look at this example. It's saying that you go through all the elements and like an third element will be printing, like in skipping 2 elements, and third one, it will see 1 and 2. It's starting with here, right? 2 is been printed, and 3 4 it's not giving the results, and straight away jump into the fifth. So a step will be like use the step value to determine the step of the slicing, return every other element. So here instead of every other elements, here is every second element. So to suit this example, let's leave it to every other element only, like in 2 steps. So this is like an step ARR of 1:7, 7:2 will be like you just jump every alternative. So that's an example. So let me give one more example, irrespective of the step, but return every other element from the entire array. So there is another way also, like an array of NP array 1 2 3 4 5 6 7, print array of colon and 7. I'm not giving any values at all. Neither I'm staying the starting value, neither I'm giving the ending value, but I'm simply saying step 2. So this time I got 1. The reason behind is it's starting with the zeroth one. So 1 and 3 and 5 and 7. So I'm not even giving the starting bit and not even the ending bit. So I told you, right, in there will be starting and ending. So starting and ending, right? I'll say start and end for the slicing. Start colon end. So what we can define like start colon end colon step. Neither I'm giving the starting, neither I'm giving the ending, and simply saying step. So that is what it's happening, right? So here the thing, it is giving all the bits like colon 2, in the sense either I have to give 1 and 7, something like this, but I'm not giving anything. So in that case, it's treated with 0, 0, 0:0:2. So what it does is, that's the reason it says 1 2 3 and 5 7. 1 1 3 5 and 7. 2 steps it is jumping across, and it is giving all these elements, right? So let's they got a few more examples. I think you guys can bear with me. So that we'll finish off this arrays concept. There are still some more arrays concept in this NumPy, but we have taken a few examples today. So let's see slicing 2D array. From the second element, slice the elements from index 1 to index 4. So see, the index 4 is not included. So that's the reason. So I'm giving this 2D array. This is a 1D array. And this is again 1D array. But since we are enclosing within the braces, this now becomes a 2D array. 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. And this time I am saying print array and 1, 1, colon 4. See? So from the second element, right? From the second elements, okay. So I want 1 colon 4, like AF0, AF1, AF2, AF3. So fourth one, the last one, it won't print. So when I say, if I say AF0 will means it will pick up this first dimension, but I'm not going this first set, right? So since I'm saying that 1, so it will go to the second dimension set, and it will start with, again it goes to the, this 1 comma means it goes to the second dimension set, and 1 comma 4 in the sense here to here. AF0, we don't need AF0 is 1, right? AF1, AF2, AF3. So fourth will be skipped. So 7, 8, 9. So once you have this good practice, so in the further examples, it will be easy. So remember that the second element has index 1. Yeah, that's what. So let's pick up one more example from both elements return index 2. So what I'm trying to say is I want an element to be printed from this dimension and also from this dimension, both at a time. So array of import, I got a single dimension array over here and the single dimension over here, and once you club together it becomes a 2D array, and I want each one element from single D arrays. Okay, print array of 0 colon 2 and then the second element. So it says 3 in the sense, so here 0 1 2, absolutely. In this case 3 is the second element, AF2, AF0, AF1, AF2, AF, in this case 3, and we got 8, AF0, AF1, AF2, 8, right? We got 3 comma 8. Some both the elements return the index 2. So second index we are going to print. So this is what the method is. So AF0 colon 2 and 3, AF0 colon 2 comma 2. This is the method. So the last but not the least example, from both the elements slice index 1 to index 4 not including. So this will return 2D arrays. Yeah, this is a good example. So the same concept of 2D arrays, but this time I want to print the elements, like I want to print the elements 2, 3, 4, and I also print the elements 7, 8, 9. So 2, 3, 4, how am I going to get 2, 3, 4 and also 7, 8, 9? So it will say that AF, just keep in mind AF0, AF1, right? So it says 1 to 4 means AF1, 2, 3. Fourth element, it won't, it will exclude the fourth indexing, right? So that's the reason. So I want 2D. So since I want the 2D format, 0 comma 2 colon 0 colon 2 and 1 colon 4. So 2, 3, 4, it is picking from here, and 7, 8, 9, it's picking up from here. So how it's picking up 2, 3, 4 only means 1 colon 4. If I say 1 colon 5, and if I run it, see, I'm getting 2, 3, 4, 5. That means it says 1 means AF0 and F1. F1 will be 2. F1, 2, 3, 4. So last index, it won't, it will be excluding, right? That's what the indexing. So we need both the elements from both the 2D arrays. So this is a concept. print array of 0 colon 2 comma 1 comma 1 colon. So usually I need to print only 4 elements. So I give 1 colon 4 irrespective. If I want all, I can print it, but I just want to make sure that I want to slice the elements. So the concept of slicing index 1 to index 4 only, but don't include fourth one. So index 1, index 2, index 3, that's what I want. So this is index 0, index 1, index 2, index 3. So these elements are printed over here from the first array, and again from the second dimension, again index 1, index 2, index 3, right? So the fourth index, it won't print. So this will make it into the 2D display. So if you make the changes over here, it will convert to single dimension array. So since we are given as 0 colon 2, it's converting into the 2D array, and it is trying to fetch the values, right? So there are a few concepts which we'll be learning in the upcoming sessions also, but there is something called next session we'll try to understand like in shapes. We also gives the concepts of sorting, and we thought about filter, and we also gives the concept of reshape. Okay, reshape and shape the arrays, and there is something called iterating concepts, which we'll try to discuss. Iterating. So there is an option of search as well, search the elements. So once we understand these things, we are done with NumPy. So why? Because NumPy makes a huge difference in the data science space. Each and every machine learning code feature will be, if someone wants to learn machine learning also, NumPy makes a huge difference. It's like an base to the data science. So if you want to utilize NumPy in future, you need to understand, you need to have the basic concepts of all the NumPy. So that's the reason I've taken so many examples. In the next session, in the week 7, I'll talk about shapes, reshapes, iterating, and everything. It's all related to the NumPy. And with that, I'll cover like a week 7. Okay. So once we are done with this NumPys and all, in week 8, we'll start with the Pandas, the key portion. So once we're done with the Pandas, good to go with this data science space of Python. It's like a full-fledged solutions once we have the NumPys and Pandas. And the last bit will be like a graphical representation, how we can use this graphics, like instead of using Power BI software to visualize the data, or to use a Tableau or ClickSense to visualize the data. Here we can use Python itself to show the data in the graphical representation, visualization format. So that's a advantage. So what I mean to say is NumPy Pandas are like in basic foundation for the data science space, right? So Python data science space. So next week, once we complete this NumPy, then especially as I said, we'll talk about the shapes, we'll talk about the reshape, I'll talk about the iterating, how we can do the iterations, and also search options, right? How we can pick an element and search and pull the element, and sorting the arrays, and also filtering. So once we understand this, then we'll get onto these Pandas. Pandas are nothing but again the file operations. You got a text file, you got an Excel file, and you got a CSV file. How to read the elements from the CSV file, how to understand the notepad file, like in text files. So especially people use Excel files. Excel contributes a lot of data. Everyone wants to store the data in the Excel format, and we can use anything, like, and we can use the JSON also. It's a lot many formats. So there's a lot many methods. But before heading up to this file section of Pandas, so we'll complete this NumPy. Shapes, reshapes, iterations, and so far what you've learned today to revise in these sections. Today we learned Okay, NumPy. What's NumPy and why we are using NumPy? Numerical Python and arrays, the single dimension array and the double dimension array, 2D array, 3D array, and how we can represent the 4D arrays also, like in 5D. 5D, right? We have taken one example, right? 5D. This is what the 5D is. So arrays is nothing but like in the matrix. So we have learned this thing. And numerical Python NP, uh, Python numerical libraries, how to import the numerical libraries, importing libraries and library, and how we can utilize them. So the alias format of NumPy, that is what each time I say np dot is nothing but we are representing NumPy. So yeah, discuss all these examples. So in the next session, we'll talk about under few examples of NumPy, and then I'll see if time permits, we'll get onto the pandas. Otherwise, in week 8, we'll jump onto the pandas. But within 8 weeks, my plan was to give the complete overview of understanding of Python and the data science, and also a few examples of the graphical representation. If required, I'll take 2 more classes for graphical representation, like an Matplotlib and Seaborn. They're also there. Like in, if I say in a simple term, week 8 will be like pandas, and week 9 will be like Matplotlib. So Matplotlib, again, the concept of graphics, and there's something called Seaborn. So these two we can give, or else if it goes beyond that, we can uh, make it as pandas, 2 sessions of pandas, and week 9 also I can continue with on pandas. Okay, and week 10 I'll finish off with Matplotlib and Seaborn. So if someone wants to apply for this Python roles also, once you have the clear concepts and clear practice, easily people can jump into this data science space, or like and become a Python developer. There's a lot of roles in overseas as well across the globe. So yeah, thank you everyone. And if you have yes, maybe because it excludes the end value. Yeah. That's what I was trying to say uh, during this example, right? Minus C and -1, 8 is excluding. So that's the reason we didn't get 7. That's what I identified. Yeah, that's a good catch. So this is something like each and every minute bits and pieces we need to keep in mind. Why? Because it's like there's a lot of sensitivity. So which elements we are trying to read, and which elements we are trying to print, and where we are starting the element and where we are ending the elements. So that's the reason we need to be careful, like in how to represent the values. We are representing in the 2D array format or the 3D array format. So since you got a 2D array, and what elements we are trying to fetch the elements, and what we are trying to display from where to where. So that is what we looked at this arrays concept here. And thank you for joining the session. And you can also put the comments in the WhatsApp group if you have. I will also post the recording video as well. And just pausing the